The 5 is
Okay.
9.
Okay.
Okay. We're in group 4.
No,
So our problem is like A, B, and C. Use the comparison theorem found on page 525 of the text to show the divergence of the improper integral 1 to infinity 1 over x square root 1 plus 1 over x to the 4th dx. And then part B says, let f of x equal 1 over x. Denote R to be the region between the graph of f and the x-axis on 1 to infinity. Let S be the form generated by revolving R around the x-axis. Can you fill the horn with 3 cubic units of paint? If not, how much paint is needed if it's possible? And part C says, show that there isn't enough semi-gloss paint on the whole planet to paint the surface of the horn. But of course, you can dig up enough paint to cover the surface of the horn from x1 to x5. Roughly, how much paint will you need? Alright, and so for part A.
Okay, so for part A, we have to prove the divergence of the function in question. So if we're proving the divergence using the comparison test, what kind of function do we have? The function is greater than or less than? That's the question. If we're trying to prove the divergence using the comparison test, we find that function is greater than or less than?
You're trying to find less than.
Okay, so we're going to use g of x is 1 over x. 1 over x is the harmonic series. Since 1 over x, a function less than f of x diverges, then f of x must diverge as well. Okay, so as we can prove right here, we take the integral, the limit as b approaches infinity of the integral of 1 to b of 1 over x. If we anti-derive, we get ln of b minus 1. If we continue, we get infinity minus 0, which is divergent. This proves that 1 over x diverges, which in turn proves that f of x diverges.
Part B. So we drew the graph of 1 over x, and then we rotated it around the x-axis, and that's like our side 2D view drawn out. And then now we go to our steps. So we need to find the volume of the solid that we graphed, and in the bottom right corner you can see a sliver of the whole solid that we because we took a cross section, vertical cross section. And so although the equation makes the graph it'll just keep on going infinitely, and it'll never reach 0, but so solid just kind of keeps getting closer and closer to 0, but never ends at a point to close off the solid. But we can find what the volume is using the integral, because the limit allows us to find what the volume is approaching to. So to solve for the volume, we take the slab of the shape, and we know that that a circle is pi r squared to find the total volume, and pi r squared delta x is to find the total cubic units of volume, and we need to find what r is before we can move on, because there's too many variables to make the integral without coming up with too many problems. So we can find r by subtracting the top of the top line by the bottom line. So if you go back here, the top curve is the y top, and then the x-axis is the y bottom. So we'll do 1 over x 0, which is just 1 over x for our value of r. And to continue, we must plug in the volume of the slab into the integral that goes from 1 to infinity to find the volume of the revolved graph. So setting it up in the equation, we have v equals pi integral 1 to infinity 1 over x squared dx. And we know that we need to take the limits of v as it goes to infinity of 1 over x squared dx, and then we will next we take the antiderivative of 1 over x squared, which is negative 1 over x, and we will take the limit of b as it goes to infinity pi times 1 over b minus negative 1 over b minus negative 1 over 1, which is just simply pi times 0 plus 1, which is just pi. So our conclusion is that volume comes to be pi units cubed, and because pi is bigger than 3, we know that we can fill the horn with 3 cubic units of paint.
Okay, for part C, we're gonna first prove that there isn't enough semi-gloss enamel on the planet to paint the surface of the horn. So to do that, we're just gonna integrate 1 over x, since 1 over x is our radius, and we're gonna multiply that by 2 pi. So 2 pi integral of 1 to infinity 1 over x dx. You can see the math. It diverges. Right? And now we're gonna see what happens if we evaluate the function from 1 to 5. But before I go to that, I just wanna let's brush that somewhere like this. We can fill the horn with a finite amount of paint, but we can't cover the surface area with a finite amount of paint, which is it's paradoxical, but the reason is because as this tends to infinity, the area gets so small that one paint molecule is larger than the area of the horn. So it just stops, right? And you get pi units of paint. So we can, of course, do it from 1 to 5. Okay, so we're gonna evaluate the function from 1 to 5, and the integral is gonna be 1 over x times the square root of 1 plus 1 over x to the 4th. That's not what the slides show, but that's what, I'm just gonna do it here, okay. So, surface area is the integral of 1 plus f prime of x squared dx. Our radius, which is our f of x, is 1 over x. So f prime of x is 1 over x squared. Okay? So we're gonna multiply this by our radius. We're gonna plug in this here. Okay? So, oh, and we're gonna multiply by 2 pi. Right? Because area 2 pi. Yeah. So 2 pi, the integral from 1 to 5, f of x, our radius, times 1 plus 1 over x to the 4th. Right? I don't think they can see, so. Yeah.
Well, it's all about Rich.
No, but like they need to. Never mind. Okay, so this integral is very hard, but it should give you a finite amount. It converges. It has a value. It exists. We don't have that value yet, but we will share it with you when we present to the class.
Okay.
It's okay. Let me just tell you why. Okay, come here. This gives you 2 pi times 1 over 2 times hyperbolic arctan of 1 root 1 plus 1 over x to the 4th minus 1. Okay. So this is what we have now, but we're not sure of the math. But we do know that, of course, this it converges from 1 to 5, so there it exists. But yep. Any questions?
Yeah.
Do you get like the paradox and the math is cool?
Is it?